Hello everyone, welcome to another lecture of University Prep Calculus. This lecture will be covering function and models. We'll focus on linear models and polynomial models. We know from the formula linear model is y equal to mx plus b. M is the slope and b is the y-intercept. So let's think we have a function given, this linear function y equal to 2 over 5x plus 3. So 2 over 5 is the slope and 3 is the y-intercept. So we can write the y-intercept 0, 3 because in y-intercept this is equal to 0. Okay, so we know one point is 0, 3. To find the other point, we can do this. We can find the x2 by adding x1 to the delta x. We know x1 is 0 and delta x is 5. So x1 plus delta x 0 plus 5 is equal to 5, and y2 is equal to y1 plus delta y. So we know y1 is 3 and delta y is 2. So 3 plus 2 is 5. So the new point will be 5, 5, 5. Or if the graph is given like 0, 3 and 5 and 5, you can take these 2 points and we can find the slope. The formula of slope is y2 m is equal to y2 minus y1 x2 minus x1. So x2 will be the numbers on the further right, and any number corresponding to x2 will be y2. So more right is this point. So x2 is 5, y2 will be 5, x1 is 0, y1 is 3. So y2 minus y1 5 minus 3, x2 minus x1 5 minus 0, it gives us the slope 2 over 5. Now we look into polynomial function. The polynomial function can be represented into this way. Why we have a to the power 0? Because x to the power 0 will give us 1. Anything to the power of 0 is 1, we already know. So that's why a to the power 0 will be multiplied with 1. So we are not writing the 1. So and n is a non-negative integer, and a1, a2, a3, these are all coefficient, any real number. So to find the degree of the function, the highest degree will be the highest polynomial or highest coefficient of that function. So for this example, the highest exponent of this function is 7. So this is a degree 7 function. The highest exponent of this function is 1. It's a degree 1 function or linear function. This one is 2. It's a quadratic function or degree 2 function. This one has a highest exponent of 3. It's a cubic function. The formula for polynomial can be written in y is equal to x over n. N is a positive number and n is greater than 1. So for example, you have x to the power 2, x to the power 3, x to the power 4, 5, 7. So x2, x4, x6, these are all even function. So they all look like parabola, but we can see the difference. X2 and x4. x4 is more flatter than x2. x6 will be more flatter than x4. Same with the odd function x3 and x5. x5 is flatter than x5. x5 is flatter than x6. If we will learn in future that x2, we remember from one example we did in previous lecture, x2 will have only 2 solution, x4 will have 4 solution, x5 will have 5 solution, x3 will have 3 solutions. So depending on the exponent of the function, we'll have the number of solution of that function. Now if a function is exponential but less than 1, positive, then if this is how it is going to look. If it is even function, is just gonna be hyperbola, because it's square root x. We cannot have any negative value inside the square root, so that's why you don't have any negative side here. so it can only be positive because root x can only deal with positive. If you put a negative number here, you're going to have a complex number which is not a real number. For a square cube root 3, you can have both positive and negative, so that's why it goes from negative infinity to positive infinity. If you have a fractional exponent x negative 1, you can also write over 1 over x, or if you have, sorry about that, if you have x negative 2, you can write 1 over x2, and for 1 over x1 the graph will look like this, and for 1 over x2 the graph will look like this. So if it is a fractional exponent, it's always gonna be fractional exponent with positive exponent, and the graph will look like this. There will be no negative graph. And if it is a fractional exponent with odd exponent, fractional odd exponent, then it's going to look like this. Nothing will be here. So I think this is pretty much it. In next lecture we'll be learning about rational function and trigonometric function. Thank you, and don't forget to like and subscribe.